Hello everyone, my name is Mayank Soni and my topic is asymmetric inverting Schmitt trigger. So let's begin with this. Asymmetric inverting Schmitt trigger. An asymmetric Schmitt trigger is a type of electronic circuit used in digital electronics and signal processing. It is a specific configuration of Schmitt trigger, which is a circuit that converts an input signal into a square wave output with hysteresis. The term asymmetric in the context of a Schmitt trigger refers to the fact that the voltage levels at which the circuit switches between its high and low states are different. In a standard symmetric Schmitt trigger, we know that the upper and lower threshold voltages for switching are the same. So in an asymmetric Schmitt trigger, the upper threshold voltage, that is VUT, this is the voltage level at which the output switches from a low to high state. It is higher than the lower threshold voltage. In lower threshold voltage, which is represented by VLT, this is the voltage level at which the output switches from a high to low state. It is lower than the upper threshold voltage. We'll see the circuit diagram of the Schmitt trigger, asymmetric Schmitt trigger. So the input voltage is provided at inverting pin, and R1 and R2 along with a supply voltage V is connected in such manner, and output is taken at this side. So we will apply KVL in this loop and we will get the equation V naught equals to IR1 plus IR2 plus V. On solving this, we will get equation of I V naught minus V divided by R1 plus R2. From the circuit diagram, the threshold, that is the triggering point, can be calculated as V threshold Vt equal to IR2 plus V. On substituting the equation of I in the above equation, we will get Vt will equals to R2, R1 plus R2, V naught plus R1 divided by R1 plus R2 V. So on analyzing this equation, we will get to know that when V out equals to plus V set, the threshold voltage is positive, and when V out is equals to minus V set, the threshold voltage will be negative. We'll see the graph of this input output waveform. So when the V in is less than VUT, we will get output as plus V set. When the V in crosses the upper threshold voltage, the output is minus V set. Similarly, in lower threshold voltage, when it is below lower threshold voltage, the output is still minus V set, and when it trespasses a lower threshold voltage, the output becomes plus V set. Similarly, this follows in all other cycles. The transfer characteristics are such as when V in provided, it is plus V set. When it crosses VUT, the upper threshold voltage, it becomes minus V set, and it continues to be minus V set till VLT is reached. So at VLT, it again becomes plus V set. So an asymmetric threshold in Schmitt trigger provide designed to flexibility for circuits, specifically advantageous for handling input signal with varying voltages levels, ideal for application demanding precise control over switching points. Hysteresis in Schmitt triggers aids in effective noise filtering and debouncing, applicable in signal conditioning, waveform shaping, and digital signal processing. Upper threshold voltage and lower threshold voltage, that is VUT and VLT, values are adjustable. Adjustment caters to the specific designs requirements of the circuit, and the choice of asymmetric threshold is contingent on input signal characteristics and desired circuit behavior. I hope you like the content. Thank you.